All right, Monday's lesson 11, finding intersections. So the first part is just kind of talking about a warm-up. And you can see I already have some stuff written down here. That's because I made a different video and messed up. So we're gonna just run it back, but I already have the same notes or whatever on here. So it says to identify a point where these two graphs intersect. And at this one, you can see that it intersects at 3 and 3. So they say to do it mentally. I'm just gonna show you how to do it on your calculator because it makes life way easier. So what you're gonna do is you're gonna go to y equals on your calculator, and then you're just gonna type in each polynomial or each equation. So in this case, it's x and then 3. So we use the variable button right here for x, okay? Don't type in alpha x because it won't read as a variable. This is x, and then we're gonna have 3 for the second equation, and then you're just gonna graph it. So then what pops up is your standard 10 by 10 viewing window. Okay, we talked about viewing window last week. So you guys can see where it intersects right there. If you can see that clearly, go ahead and write it down. We already know that it's 3 and 3, so you kind of see 3 and 3. But a lot of times people have a hard time seeing it on these graphs, and that's okay. So what you can do is you want to look at the table. So a table typically is like a T-chart with X and Y values. We have that, and then we put it on a graph. So what the calculator does is it gives you your T-chart already. So you can just look and see what points are included on these two graphs. To get there, you hit the second button, and then you hit graph, and that takes you to all your X and Y values, and you can go positive and negative and whatever, okay? But if you go back to the graph, you see that this intersects in a positive part of the graph, so all we care about is positive numbers. So anyway, when you're looking for intersections, you're looking for where both of the y values are the exact same number, okay? So if you look at this one right here, the blue graph and the red graph are both at 3, right there. So your intersection point is 3 for the x value and then 3 for the y value because they're both the same. All right, so when you move on to the second one, we have a factored form polynomial right here, x plus 3, x minus 3, and then 0. So we're just graphing that mother. All right, so you can already see the two intersection points. Those are going to be your x-intercepts or your zeros. But if you want to see exactly what they are, you can go to the table. And if you look at the table, they're both the same right here at positive 3. So we have 3 and 0 as one intersection point. But if you go to the graph, we saw 2 of them. So this is 3 and 0, but we also have a negative value as well. So let's go up to the negative numbers, and that's going to be negative 3 and 0. So your two intersection points are positive 3 and 0 and negative 3 and 0, and that's just straight from the graph, okay? Not building rockets here, pretty simple. So this one, we have x plus 3, x minus 3, and then just x minus 3 for the second equation, okay? Graph that. There's our parabola. There's our next one. So you can see we have two intersection points. If you look, we're going to have an intersection point that's positive, and we're also going to have one that's negative because it's on the top or the bottom half of the graph. All right, so these are kind of hard to see. I'm just going to go straight to the table, and we're going to look where the y values are the same, okay? So I'm going to come up here a little bit. So here's the negative numbers. So we're kind of far. And then at negative 2, you can see that we have two negative 5s. Sometimes you're just going to have to scroll for a little bit. Okay, but this is way easier than trying to set them equal to each other and solve, in my opinion. I would rather scroll on the calculator for a little bit than spend 7 minutes doing a problem that I could potentially do wrong anyway. So negative 2 and negative 5 is one of these intersections. And we know that we have to have a positive one as well. The reason we have to have a positive one is because of this right here. Okay, this one was clearly our negative, so now we're looking for our positive. Go back to the table, go to the positive numbers, and we have one right here. 3, 0, and 0. Because those are the same, that's my intersection point. Okay, for this one, x plus 5, x minus 5, and then x plus 3, x minus 3. And I'm just going to go straight to the table. Actually, let me go to the graph. Okay, so that's one graph. We don't get to see the whole picture of it because the viewing window is bad. and then we have another graph. So you can see that the blue one is wider than the red one, and we'll see if they actually intersect. It doesn't look like they do. So if you want to zoom out and see, what we can do is we can hit zoom, and we can hit 3 for zoom out. And I would just hit enter. And that backs it up a little bit. So there's blue, there's red. They look like they're getting really close, but I don't think they're gonna touch. So let's go to the table and see if we see anything. If they do, it's gonna be up in the positives. All right, so we're gonna do some searching here. We're getting close. They're never gonna touch. You can see that I'm going up and up and up. And they're close, but they only have a distance of 16. So they're never actually gonna touch, so these have no intersection. Okay, so in your packets on 11.2, 1 through 4, what I want you guys to do is just go ahead and pause the video and try to do 1, 2, 3, and 4, identify the intersection points on your own, okay? So pause the video right now, take some time whenever you're done. I'm gonna continue to work on them to put the answers, but you should pause the video so you can actually try it on your own, okay? So assuming that this is you picking up after you left off and you pause the video, let's take a look at what our intersection points are. So we have x squared minus 7 and 2. I'm gonna graph it. And you can see that my graph is really weird right now. So I'm gonna hit zoom in 6 and go back to my standard view. Okay, you can kind of see where they're at, but I'm gonna go to the table anyway. I got a negative and a positive. Now I have to go back. The crazy thing about this is like wherever you leave off in the table is where you pick up. So if somebody in another class was being an a-hole and went to like 500, you're gonna have to go back to 0 or reset it. So, all right, so -3 and 2 is one intersection. And now I know I have a positive one, and I can see it right here at 3 and positive 2. So those are the intersections for number 1. Moving on to number 2, I got x plus 7, x minus 4, and then just x minus 4. Graph those. And I keep showing you the graph so that you can see what we're looking for. Okay, we're trying to identify that intersection point and that intersection point. Not a good viewing window, really doesn't matter. You could just go straight to the table and look for the similarities, okay? So we know we have a positive and we have a negative. This one will be positive, this one will be negative. So we're gonna look on both sides. So -6 and -10 is one answer. So now we need a positive one, and you can see that right here at 4, 0. So those are your intersection points for this, okay? Relatively simple, moving on to 3 and 4. I'm gonna make sure this is lined up so you can see it. Going back to the graph, x plus 7, x minus 4, now we have 2x plus 5 and x minus 4. I'm just gonna go straight to the table for this one so you guys kind of have an idea of what we're doing. The graph kind of helps so you can see if there's gonna be a positive or a negative. So I might end up doing that anyway, but I just want to show you can do this. So we have 1 at 2 and -18. You can see that. And then 4 and 0. And it's always a good rule of thumb to kind of check to see. That's why we look at the graph a lot of times first too, to see how many actual intersection points there are. Because if there's 3 and you see it, you would be able to see it on the graph. All right, so this is tricky because it kind of rides along right there, so it almost looks like they intersect the whole time. So what you'd want to do is kind of zoom out a little bit, or maybe even zoom in and see. But you just change the viewing window a little bit and see how many times they actually intersect, and those are the answers you're looking for. Okay, so once again, probably not the best. So in cases like this, you want to just kind of rely on the table to tell you what you got. All right, so let's go ahead and go to the next one. X plus 1, x minus 8. And x plus 2, x minus 4. Graph it, see how many we got. One. Maybe I'll intersect up there, so we're for sure looking for 1. So let's see what we got. Let's go to the table. 0, negative 8. Let's go to the positive side and see if we're seeing anything there. Okay, so you can kind of see that these numbers are getting farther and farther apart. Doesn't look like we're gonna intersect at any time soon. Now I'm down in the 30s, so I'm way down there. Still not seeing anything. We're still quite a ways off. And you kind of just keep going and getting crazy with it, and you can see that they're never gonna end up touching. So this is the only intersection point that you have. So you guys just watch me go all the way to like 58 on the x value. It doesn't take a long time, okay? It's kind of a pain because you gotta go back to 0. But honestly, what would you rather do? Would you rather type in the calculator and look, or would you rather do it by hand for 6 or 7 minutes and complain about how hard life is, and then maybe even get the answer wrong? Okay. Beggars can't be choosers, people. All right, so go ahead and try all the points of intersection for this one. So now you have a 3-factor polynomial and a 2-factor polynomial. Let's see what we got for there. Go ahead and pause the video, try this one on your own. Pick it up in a minute. Okay, assuming that this is you after you pause the video to try it, I'm gonna type in both equations. So I got 2x plus 3 and x minus 5. And then I got x plus 5, x plus 1, and x minus 3. Graph it, see what we got. Okay, so I'm going to zoom out just a little bit. Just at the center so I can see how many times we think it intersects. Okay, so there's our 2, our degree of 2. So this one probably intersects 3 times. 1, 1, 2, 3. So we should be looking for about 3 of them. So let's look at the graph and see what we see. If you look at the graph, we got a couple of ones that could potentially be negative. So let's go to our table, check the negatives first, and then right off the bat, you see at 0 and negative 15 we have a point. So 0 and negative 15. That worked out well. So then we'll go down a little bit more and see, oh, negative 3 and 24 is for sure 1. Okay, so if you look at the graph, we found the 0, 1, wherever that's at. We found negative 3, so now we should probably look for a positive value because we know that there's 3 total. There it is, 2 and negative 21. All right, so you saw me kind of go back and forth a little bit. It's easy to get lost. Just take your time, and we're just looking for when both numbers are the same here, your answer is the x and the y value. Okay, that's your intersection point. All right, moving on to 11.3. All right, so the way that they're gonna say this is they'll say, here's your polynomial, here's just a regular equation, a constant. Use graphing technology to find a value of x that makes p of x equal q of x true. So right here, all that means is look for intersection. Okay, all that means is you're gonna look for intersection. So when you look for the intersection of this one, you plug both of them in. 5x cubed. So this is the first time we're typing in a standard form, but it's still the same thing. Okay, so you're just gonna type it in, and then we're gonna go to 5640, graph it. You can see that I'm still zoomed out from the previous problem. Not a big deal. If you don't like how it looks, you can change it. And you can see that you only see one line here because 5640 is way the frick up here, and it's just gonna be a straight line. I'm not gonna mess with the viewing window. I'm just gonna go straight to the table. as you see here, we got 10 at an x value of 5640, 5640. So my intersection is 10 and 5640. Not 10,506, not 10,000, 5,640 or whatever, but 10 and 5640. All right, so what that means is our solution here, or the value that makes it true, basically is x equals 10. Okay. So for the value, for the x value at the point of intersection, what can you say about the value of this? So if I plug in 10 for all of these, if I plug in 10 for the x's, it's going to be equal to 5640. That's what this means. If I plug in 10, 5640 is my answer. Okay? So then if I put minus 5640 on the end of this, all right, let me explain that one more time. If I take 10 and plug it in for this, this, and this, my answer will be 5640. Okay? Plug in 10 here, here, and here, I get 5640. So then if I subtract 5640 from this, I'm getting 0. My answer is equal to 0 because I subtracted my answer. Okay? So what does your answer suggest is a possible factor of this? That means that 10, if x equals 10 as a factor inside parentheses, it's x minus 10. That's why it's called factored form. Parentheses are factors. This is your x value. This is the factor of that x value. Okay? So the whole point of this is what we're starting to look at is two polynomials, what the solution between those two polynomials is. That's going to give you your x value, which ultimately gives you your factor, and that's going to lead into division of polynomials tomorrow and on Wednesday. Okay? So go ahead and wrap up your notes. Don't worry about doing it on your own, and go ahead and transition into the homework piece of your packet.